Welcome back to your channel Rayofhope, and this is going to be the third lab for our AWS Solutions Architect Associate. In this lab, we're gonna cover how to create a database layer in your Amazon VPC infrastructure. We have already launched the lab. This is how the lab looks like. Basically, here it says a backend database plays an important role in any environment, and security and access control to its critical resources is vital to any architecture. In this lab, we're gonna create Amazon Aurora database cluster called cluster to manage MySQL database and an application load balancer and so on. Basically, by end of this lab, we would be in depth of learning how to create Amazon RDS database instances, how to create application load balancer, how to create an HTTP listener for the application load balancer, how to create a target group, register target with target group, test the load balancer and the application connectivity to the database. Review Amazon RDS DB instances metadata using the console. Optional task: create an Amazon RDS read replica in a different AWS region. So basically, what are the prerequisites do we have? A notebook computer that we have, a Wi-Fi, Microsoft, Windows, Mac OS or Linux. So these are some prerequisites. But before we get into, we need to understand what is Amazon relational database services. What is there's a difference between relational database and Amazon? Let's see that. Basically, when we talk about Amazon RDS, it is used to manage database service provided by the AWS. So here you would not need to install, configure, patch or maintain any relational database manually. AWS will do all of it. That is why it is known as Amazon RDS. Most important, it lets you to set up, operate, scale relational database in the cloud environment without worrying about any hardware backups or OS level management. You do not need to do anything. You can just access each and everything. You can have your database without having any hardware devices, and you can do that. Most important, RDS, AWS RDS mostly support MySQL and Postgre. These are the preferred for the RDS, AWS RDS. However, it does include like MariaDB, Oracle, and also SQL Server. I believe you have the basic understanding of AWS RDS. Let's go ahead and open the console. Now, I'll go ahead and look over. Okay, these things we have already did it. Choose the open console, and this is the lab environment now. Okay, do we need to read it? The lab environment provides you with the following resources to get started: AWS, Amazon VPC, yes, and security groups to control inbound and outbound traffic, 2 EC2 instances in private subnets, and an associated EC2 instances. The instances profiles contains the permission necessary to allow AWS System Manager, Session Manager feature to access EC2 instances. Cool. Here, now we can see this is how the labs look like. Well, you already know about it. I have demonstrated it in our previous 2 lectures, right? Now, we have S3 bucket, we have RDS, we have EC2, VPC and so on. Now, what do we need to do in order to get started to create the first RDS? It is saying at the very top of the AWS Management Console in the search bar, search RDS. So, I have already bookmarked it. I'm just gonna go ahead and click on it. What it says now, in the left navigation pane, choose database and choose create database. Now, we are on the page of RDS where there we can create a database. Now, we are in the dashboard. We will go ahead and click this databases. Once we click the databases, we have something called create database. Let's click on this. Once we choose to create that database, it will have in the choose database create command section standard create. Okay. In the engine option, select configure engine type or a MySQL compatible. Okay. So now it's loading. Okay, it's already standard. As you can see, it's standard engine option, we need to configure MySQL. Aurora MySQL compatible. It's a PostgreSQL, but I would need to go for MySQL. Okay. Now, do we need to add engine version as well? No. In template section, select div and test. Let's scroll it down, or let it load actually. Okay. Use for production environment, but no, we are not getting into production as of now. We are into UAT. We will click on div and test. We have setting database cluster. Now what it says in the setting icon, configure the following: DB cluster identifier Aurora. So I'll just go ahead and paste this Aurora here. Now what it says, master username, enter DB admin. So here it's admin, but I'm gonna change it to DB admin. Now we have credentials management. How do we want to manage our credentials? Okay, under credentials management, select self-managed. It is selected managed in AWS sector, most secure, but I would need to go for self-secure and set my own password. How we do gonna do that? Master password, paste the lab password. We have the password over here. Here we're gonna copy and paste it. Again, I will paste it. Cool. Confirm password and it's done. In the instances configuration, select section, configure the following: DB instances class. DB instances class. Okay. Select burst table classes. So this is what I need to select. It's DB T3 medium. It must be the same. Choose DB T3 medium instance type. It's already there. In the availability and durability section, for multi-agent deployment, select don't create an Aura replica. Don't create an Aurora replica. It's already marked into the same category. Now, once we get into this, in the connectivity section, okay, let's know this. AWS recommends that you distribute the primary instances and reader instances in your DB cluster over multiple availability zone to improve availability of your DB cluster. This way, an issue that affects on entire availability zone doesn't cause an outage of your cluster. This is why you can set up a multi-agent DB cluster by making simple choice. When you can create the cluster, you can also convert an existing Aurora DB cluster into multi-DB cluster by adding new reader DB instances, specifying a different availability zone. Right now we don't need that. Okay. In the connectivity tab, virtual private cloud, we learned about that in our previous lab. Select lab VPC. From where we are getting this lab VPC? We created this in our previous module. Got it? Now I selected the VPC module. Now connectivity tab, right? Yeah, it's connectivity tab. Then VPC module. Then we have DB subnet. Select lab DB subnet group. So here lab DB subnet group, this is the same only, and that is okay. Public access, do we want to give the public access? Obviously no. Then now we need to configure the VPC security group, which is a firewall. How are we gonna do that? Existing VPC security group, just cut it. I don't want default one. I want lab app security group or lab DB security group. Which one do we want? What it is saying? Remove existing, select text, next section is drop command lab DB security group. So obviously we are doing for DB. So now we will select for lab DB security group. Okay. Availability zone. Which one do we want? US based 2A or 2B? We are into 2A. But what the section do they want actually? Remove it. Okay. Now availability zone, no preference. Subnets are segment of an IP address Amazon that is designate to the group your resources based on security and optional needs. A DB subnet group is a collection of subnets that you create in an AWS VPC and then designate for your DB instances. Okay. So with the Amazon VPC, you can launch Amazon resources into virtual network, public and private, that you have defined already in our previous module. This virtual network closely resembles a traditional network that you would operate in your own data center with the benefit of using a scalable infrastructure of AWS. Okay, let it be. In the monitoring section, we select enable enhanced monitoring. So in the monitoring section where it is disable. Okay. Now expand additional configuration section, which is here, and we will need to put our initial database name, and that I'm gonna put as an inventory. DB cluster name, we will need to go for lab stack, and from where we are getting, you can see here it is already defined actually, lab stack FA5698D. You can see, right? DB parameter group, let's just keep it as it is. Now, okay, in the encryption section, unselect enable encryption. Unselect. Now, what else do we leave? Okay, done. In the maintenance section, unselect enable 2 minor version update. Okay. Now, scroll to the bottom of the screen, then choose create database. You can see just to create one database, it will cost you about $60. Just to create one database, it will cost you $60. So now let's create a database. Okay, so here we not need to do anything, just close it. It is creating the database called Aurora. Finally, the first task over here, creating an Amazon RDS database, has been completed. Now we would need to create and configure the application load balancer. And how do we gonna do that? Might take few minutes to launch. You can use setting from Aurora to simplify configuration of suggested database. Let's wait for it till the time it is getting created. I'm just going to pause the video. Cool. You can see now the database has been created. Here you can see refresh button. I can just go ahead and refresh it. Okay. Now, your Aurora MySQL DB cluster is in process of launching. The RDS database can take up to 5 minutes to launch. However, you can continue to the next task. Okay. Now we need to do the create application load balancer and configure it. So what is load balancer? A load balancer serves as a single point of contact for clients. Clients send requests to the load balancer, and the load balancer send them to the target, such as EC2 instances. To configure your load balancer, you create the target groups and then register target into your target groups. Cool. How we gonna create the target group first? At the top of the console, in the search bar, search and choose EC2. Well, I can just go ahead and click over here. It will get me to the home page where I have all the things. Recently visited, favorite item. This is the best thing I like about AWS. Click over here, EC2. Now, once we get into EC2 instances, in the left navigation panel, you can find load balancer and select target groups. So yes, here in the EC2 instances, we have something called load balancer here. And in the load balancer, we have something called target group. Let's click on this. Once we click on target group, it will ask me to create a target group. And what name I'm gonna give to the target group? ALB target group. And then it should show me a target page. It's just loading. Now here we have create target group. There's no group that has been created. Let's create one. What name is it? Says ALB target group. Obviously I have to go for instances only. Target name group, ALB target group. Protocol will be HTTP and HTTP. IP address IPv4. No default. I'm gonna choose LP lab VPC. Protocol HTTP 122. Just keep it default only. Let's see if we are missing anything over here. Target, select LVC. Choose next. Register. Okay. Next. We don't need to do anything. Just click on next. Now you can see there is 2 servers that has been added to our register target. Now which app server do we gonna use? Let's see. Create a application load balancer. Once we create this, okay, first in the available instances section, configure the following. Select EC2 instances name A and 2. Choose including as below. So now I will select both and then include as pending below. Okay, now this is in the target. Okay, now we can create a target group from here. Okay, now it be added those. Okay, you can see create target group. So let's just create a target group. Cool. Now we have created our ALB target group, right? Sometimes you would need to wait, not need to be in a hurry. Okay, and you have to make sure that all the rotations or that is just getting done. Okay, now once we create a load balancer, you can see in the left navigation, expand load balancer section and choose load balancer. So again, now we are into target groups. This module we have to get into load balancer because that is what we need to set up. Okay, once we get into load balancer, definitely we would not have anything, so we would need to create a load balancer. And what the name do we not give it? In the load balancer type section, for application load balancer card, choose create. Create application load balancer. So I'll click on this. Okay, now we are into application load balancer and we would need to configure it. So load balancer name, we're gonna put it lab app alb. Load balancer app app alb. Internet facing internal. Keep it as a internet facing. In the network mapping section, configure the following. VPC virtual private network. So definitely I will keep it as a lab VPC. Now, do I need to use the IPAM tool for the public? Let's see. Okay. Mapping. Select checkbox for the first availability zone listed and select public subnet from the subnet list drop down menu, and the same for public subnet 2. How we gonna do that? So once we select it, this is a subnet 1, 7, and now this is 2. This is public subnet 2. Okay, do we need to change? There are 2 only. The first is for first, the second is for second. Now we have selected the 1 second. In the security group, that is again the firewall path, configure the following. I would need to cut it here. Lab DB security group. Obviously we are dealing with DB, so we would go for lab DB security. But let's see what they are saying. Lab, select lab ALB security. So no, we not need to deal with database but application. So here we have lab ALB security group. So we select it, right? You can see lab ALB security. In the listener and routing, listener HTTP port number 80 from the default drop down menu, select ALB target group. Okay. Now we configure, choose the load balancer, choose create load balancer, and it will create a load balancer. Keep all the setting as default and just create a load balancer. Now we finally created one load balancer, the first load balancer. How we can configure it? We did it actually. In this task, we created ALB and we added EC2 instances as a target to the load balancer. This task provides a demonstrator on how to register target with the load balancer. In addition to individual EC2 instances, auto scaling groups can also be registered as a target to the load balancer. When you use auto scaling groups for targets for the load balancing, the instances that are launched by the auto scaling group are automatically registered with the load balancers. Cool. Now we are done with this creating and configuring the load balancer in an AWS environment. Now we would need to review the Amazon RDS relational database, right? DB instances for metadata through the console. Again, I would need to get into this Aurora and RDS. Click over here. It will give me the RDS console. Again, I would need to choose this database page. Let it load. Here we go. We have this database. I get inside the database console. From the list of DB identifiers, select the hyperlink for the cluster name Aurora. Okay. Let it load. I have this hyperlink. So I just clicked over here. Now we are into the page. We have a page now. Connectivity, monitoring, logs, configuration, and a lot about this. Okay. On the connectivity and security tab, you can find the endpoint and a port number for the database cluster. In general, you need the endpoints and port number to connect the database. Do we have it? Endpoint and port number, right? Okay. Now copy and paste the endpoint writer value in a tool notebook. You need this value later in the lab. So let's copy this. Let me delete all this. Copy then paste the endpoint name and the writer instances. (3306) port number. Second endpoint, it also has the same port. Okay, this is the first one is writer, and this one is the reader. Okay. Now to copy the writer instances in endpoint, over it and choose it. Okay, this is where we have. This is the endpoint, right? Notice the endpoint is available, or definitely it is available, right? Now on the monitoring tab, you can monitor metrics for the flowing items of your database. Wait for the status of Aura DB instances is so available. Okay, it is also showing available. Only then we can see. Now let's get back to monitoring tab. It will take some time to load all of it. Okay, in the meantime, let's go for it. Okay, now we have a console. Here they can review these the amount of read and write operation in database instances, the amount of storage the database instances currently using, CPU, and all those things, right? They can monitor, they can read, and they can analyze from here, right? It is working. Cool. Now we have reviewed the Amazon RDS DB instances metadata through the console. So third task is also done. Fourth, test the application connectivity to the database. How to do that? Now again we need to get inside the EC2. Let's get into EC2. EC2. Let me mark it as a star. Now it should be here. Click on EC2. Once I get inside the EC2, from the target group, select ALB target group. From load balancer, get into the target group. It is still loading. Okay, finally we are in the target groups console and we have this ALB targets. Let me select it. Once we select this, we have a page here. I cannot make it up now. You can see now the status of all those target group is healthy and unhealthy is 0. Okay. Now the status says display as healthy. Yes, it is healthy. What next? In the left navigation panel, choose load balancer. This is the load balancer. We must have a load balancer in here. Yes, it is here. Now copy the load balancer page displayed. Okay, once we select it, it is displayed and we have a DNS name here, that is a record. A record basically means IPv4. So to copy the DNS name browser, okay, expected, paste the value in the browser tab to invoke the load balancer. Now we copy this load balancer, we paste it over here. No, it did not load. Why? It should load, right? Copy the DNS and paste the value in the new browser. Okay, let me paste it here. No, it was generated by instances ability zone US based. Okay, just a moment. Let me traverse with this. Okay. There you go. So the problem happens, but when you make a mistake, this is how it happens. So what happened? I did not enable the protocol, which is HTTP/AT. Okay, and therefore I was not able to get it. Even though now, if I refresh over here, I should get it. Let me refresh it, or just paste it. Let it be. Now, the page was generated by instances called this in an availability zone US based 2B. Cool. Now, the page was generated by instances in availability zone US based 2A. Why I got 2A, not 2B? Even that we can configure. We can just see. Let it be. Now, at least we are able to get the web page and that we hosted to the AWS RDS, right? Now, choose the setting tab in the configuration following. Setting. Where do we have setting tab? Let me get back to the load balancer again. Okay, here we have this setting tab. So let's click on this. Database entered inventory. Choose the setting tab and then configure the following. Paste the writer instances endpoint you copied earlier. Okay. Okay, here we not need to do anything in this setting. Here we have the setting. Okay, now this is where we need to put it. Let it load actually. In setting, in paste the writer instances in endpoint. Endpoint. Okay, so basically we have the database in here, and this is where we need to put. So now database is inventory, passport is dbadmin that we created already, username actually, database inventory username is dbadmin, and passport is paste the lab passport which is here, lab passport, paste it, and I wanted to write, so this is the writer, paste it and save. Now the application connects to the database, loads some initial data and display information. Within this application you can add, edit and delete an item from the stored inventory. The connection was entered. Okay, why it happened? Shit. Okay, light got disconnected. Just a moment. Okay, we are back. So now let me just refresh it. Now you can see we have once we added the values and given the writer permission, we have a store item quantity to add it, delete it, and so on. So till now we are able to successfully access the web application that we created in an EC2 instances and created a RDS database. Now finally we are done with the lab. However, if we want to create a optional, that we definitely gonna do that, creating an Amazon RDS read replica in different AWS region. Okay, so now again for that we would need to get into RDS, which is here. Let it load. Here is RDS. Once I get inside the RDS, select DVC action, create cross region read replica. Okay, let it load. We are on the RDS console. We have this database. We would need to select the Aurora DB that we created. Let it load. Now let's select this Aurora, and I would need to click on actions, create cross region read replica. Click on this. Now the create cross origin read replica page display. Yes, here we have. It is still loading. Now for multi-agent deployment, select don't create Aurora replica. Don't create. It's already there. We have already created this, right? But again, we would need to do this for the read replica. Now in the connectivity sections, configure designation region. From the drop down menu, select the region that matches remote region. Remote region. One second. US East. Okay. US East in Virginia, right? Yes. The lab will be definitely the VPC only. Lab VPC. Okay. DB subnet will be by default. Public access no. Existing VPC security groups. Cancel this. Lab. Okay. Availability zone. Let it be now. Okay. Done. Initiating action. Configure the fluid. DB instances lab replica. DB cluster. DB instances identifier. Paste it. Done. Database should be standard only. Enable enhanced monitoring. No, we don't want actually. Create replica. Okay. Create it. Creating replica of LD. Okay. So now we did creation of Amazon RDS, creation and configuration of application load balancer, and review Amazon RDS DB instances through metadata. Test the application connectivity that we did it over here, and then creation of Amazon RDS server replica in different AWS region that we just did it. Cool. So I believe you might have learned something from this lab, and if it helps, do